this adorable little bear. But now we need a name for the DJ Hudcap, who is the bear. So later, not right now. But, so thank you for that, if that was one of you. And I would love to know who you were, if that was you. So happy Monday. Today I've heard is a special day because it is 2/14. So if you can't read this from the back of the room, my little fine print here says, day that makes single people very aware they're single and might in one day save the flowers, cards, and candy businesses. So, more cards, candy, at least chocolate hearts, and flowers are sold on Valentine's Day than like any other day. So just interesting statistics of like, well, you think nobody's going out buying last minute flowers or candies? Oh, just wait till it's your job to buy the flowers or candies and see if you remember. Gust.
Why is 2/14 a special day?
Because it's Valentine's Day.
It's actually Single Awareness Day.
Do I what? I do.
It's Happy Day that makes single people very aware.
It's Happy Do Day.
We need to take that honor.
Oh, by the way, definitely with that poor performance right there, Math 7 is trying to surpass you guys in the clapping game. So I'll give you another shot if you want. They stepped up their game pretty strong. So, plan book. I did. Sorry, yours I got first thing this morning and then I forgot about it. But thank you very much. I appreciate it. So, the whole week, you should have all of these homeworks. You should not have turned in 823 yet. However, at this point, if it's done, I'll let you turn it in. But we're going to check 822 today because that's the one that is technically due. Now hold up. Because I do not want people like upset with me or whatever. Gus, you're going to have to get past like playing with those or put them away. 822 was assigned on Thursday. 823 was assigned on Friday. So technically, me making 823 due tomorrow is not a one-day turnaround. It's really still our agreed upon 2-day turnaround. The only reason I don't have 824 right here is I don't want to stress people out if they're a little behind. But really, if you have 823 done, you should be working on 824 tonight because it's all related to each other. So let's check 822 real fast with any last questions and then turn it in. And then we want to try to get through the rest of 823 and even probably get into lesson 824. So hold up, because I got people talking. And I know this is going to fall apart because people are talking. If you don't have 823, apparently I'm out of extra copies, so you're going to need to come see me, and I'll print one for you. 824, 831, all of those are up here. So if you need 824, 831, or 8 closure, please come get it right now. Jordan.
I just got this.
What? 823? That's up to when you pick it up. So, I mean, we can say it's due Wednesday. I don't really actually care. What I really actually care about, 823? Oh, you mean there are still some over here? Oh, then I guess I didn't carry them up front. Okay, so I have one left. I got one copy left. But here's all I really care about. Our goal is to be able to start taking the mastery or like take the whole thing on Friday. So that's our goal, is wrap up the chapter through this week. So 822. We talked about some of these. We looked at this real quick last week. So ask me if you have questions. Otherwise, we should be turning it in. I think I only got like 5 of these turned in on Friday. I can tell you exactly. 5. But one of you had a check minus because you skipped the problem. So 5 of you already turned this in and got it back today. At least I hope you got it back because I think I turned back all my papers. Any questions? Except for Grant. I don't know why your paper's still sitting on my desk, but I have yours as well. Gus, question? Because they were all like in rows this morning, and you were one of the people that didn't come and help me rearrange them. So Aiden and I just put them where we put them, and I guess we just kind of put them more towards the back than towards the front. Do you guys want to be closer to the front of the room? Lily. Lily, do you need some help, or are you going to play with Max's mask, which is weird? Like, don't come that far, but that's like weird. I can't hear you.
It was just a mistake with exponents.
Ah, just a mistake with exponents.
Just a mistake. Literally, yes, just a mistake. That's what she said. Okay. That was.
All right, so no questions?
Yeah.
All right, so turn those in. What did one cat say to the other on Valentine's Day?
Meow. Happy Valentine's Day.
Holy crap, a talking cat. No.
I know.
What do you think?
You are perfect.
You're perfect.
No.
What did the chef give to his wife on Valentine's Day?
A Valentine's Day.
A hug and a quiche. What did one owl say to the other on Valentine's Day?
Who are you?
Maybe if they're doing a blind date for Valentine's Day,
Who's your Valentine's Day?
I'll be yours.
Oh!
Who always has a date on Valentine's Day?
Not you.
A calendar.
Hey, ours was pretty good.
And all you need is love. For those of you that are begging me for how do we graph a circle, this is kind of an indication of how do we graph a circle.
My mom was looking at that one.
Your mom made this. I stole it from her. I saw her this morning putting out the donuts, and I saw that, and I was like, I'm taking that. Just FYI. Like, I'll leave it here for like an hour, but I am taking that. She was like, I made it thinking about you. And I was like, good. These are all like mathematical operations, but this is absolute value function. This is a turned sine function, so you can rotate functions around. Circle functions are not that hard. What this is the radius squared. So these tick marks would not be 1 to 1, because technically the radius here would be 3. And this is a regression function. There's a lot of ways to try to make something that looks like an L. But all right, time to do math. Let's move on. Turn those in if you need to. Otherwise, it's time to boogie. So we had this on the front of 822 that everyone just got back. Are there any questions remaining on this? For our exponent rules, what do we do when we have a power to a power like we see in this table here? See, this is what I was concerned about. So give me your eyes up here. When you have a power raised to a power, to review before we dive into the newer stuff, this is like saying 2 squared 4 times. So, it's really 2 to the 8th. A power to a power gets multiplied. So this, check your table. Some of you turned this in with wrong things written. This should be 3 to the 14th power. No, but it's a good reference, right? It's good to be able to look back at. This should be x to the 15th. And this should be x to the 6th, y to the 4th. Yes, Lily. We had 2 different tables. There was another one back in. This is a different table. So what I'm talking about is on a 2-2. Or did you just turn that in? Yeah, so that is like right here. That Max is trying to frantically do because he doesn't have his homework done on time. So this table. What I'm calling you out because you were just in math class and you told me you were completely caught up. So put this away because it's not what we're doing. Oh, so you don't want to, okay, I see how it is. I
had
what
work that I needed to do because I did it wrong. I wanted to finish that first.
So chat with your team real quick. You should have graph paper out.
Wow, thanks for the confidence.
20 to, I don't know if you can really be upset with me when we don't have our homework done on time. and we're coming off of a weekend. All right, so I'll play it like this then, because some of you are obviously not doing this. I'm not passing out homework at any other point this week. If you find out that you don't have one, they're over here. 824, 831, and the closure. I mean, everything is over here. But if you need anything, just come get it on your own. 20 to the third times 20 to the eighth. What does that end up looking like? And how do we then write it in this simplified form? Questions or answers? Answers? All right, Anna, tell us about this. So guys, we're going to keep toggling back and forth between the different rules. This is you have 20 times 20 times 20. This is the same thing except for there are 8 20s. So in total, we would have 11 20s, which is where if I made you write it out, that'd be like cruel and unusual punishment.
Oh, wait, we don't have to?
So are these identical?
No.
Get graph paper. I'm not your maid.
Yes, I can answer. No, they don't.
Talk with your team. 30 seconds. Are these identical? I'm actually kind of OCD, so I do enjoy like doing dishes and stuff. So you're not wrong.
And then the other one is
I will try not to say actually, with you guys only having 3 Maddie, what do you think? Is 2x to the third the same as 2x to the third? Hey, bring it back up front. So Maddie says no, they're not the same, but I just read it. 2x to the third and 2x to the third. I said it exactly the same, Amelia.
But they're parentheses. So, like, in the first one, the 3 is distributed between the two. Like, so it would be like 2, like, 2 times 2 times 2 times 2, and it'll be like x and x. But in the second one, it's like 2 times x, 2 times x, 2 times x.
So mathematics has fixed the fact that we would say this the same. We don't say this the same. When we have the parentheses grouping the 2x, we throw in a couple extra words to clarify that. Do you know how we say it?
Is it?
Starts with a Q.
I was gonna say starting parentheses.
Nope. That's so simpler than that. The quantity 2x cubed. Did you actually know that? Okay. You dropped your hand like you were mad at me for not calling. So we would say the quantity 2x cubed versus 2 times x cubed. Right? We would read this 2 times x cubed. We would read this the quantity of 2x cubed. And it's kind of like how you put your emphasis.
My mind is blown.
Bro, at some point you got to stay in my room because you showing up here, then left to get your playing book. Showing up here, I took your homework away from you, and now you're going to go to the bathroom. Like, at some point, I need you in class.
You mean in process?
So, 5 to the 7th over 5 to the 3rd. Write this on your graph paper. 5 to the 7th, that's a highlighter. It's 64. If you're wanting to be able to label your paper. Now, I thought that we had quickly covered this one day, but that's the problem. We quickly did it, and we didn't all retain it. how would I expand the numerator? I got to keep using cards. I've already called on you. Jordan, how would I expand the numerator? How would it look written out? Jordan's like, what did I do to deserve that punishment?
No, you have to add one more time.
Ah, you are right. I dropped one. Forgot one. And Connor, how would the bottom look expanded out?
5 times 5 times 5.
And Colin, what can I do anytime I have like a number over itself?
Take it out.
What do you mean? Why?
Because this is divided by itself.
Careful, remember you're in a public school. It's a giant one! So, this really, what do we actually do with these exponents? We subtract them because this becomes 5 to the 4th. And if you want to put it over 1, you can, but it's kind of silly. We don't need it over 1. Max? Okay. I got over that years ago. I got over that probably right about the time that you were born, and I became a teacher, and kids were like, I hate you. And I was like, okay, that's my job.
It's not his job to make you like him.
The giant one is horrible. No.
Now, do you actually have, I don't want to go down this rabbit hole because we don't have time, but like when you think about this, I think you guys all, however you were taught about the giant one, hearing one of those memory tricks, you got really tired of it. There's nothing wrong with the giant one. What it's actually doing is letting us simplify and get rid of numbers.
I think it's just its name.
Without, okay, so here's part of your homework. Think of a better name for the giant one so future generations of phoenixes. What is plural of phoenix? Phoenixes? Phoenixes? So future phoenixes can not hate the giant one. We need to rename it. We need like a phoenix version. We need to burn it. We need to light it on fire and burn it. And from the ashes will rise the phoenix version of the giant one.
That was a great analogy. That was
Well,
I have an idea.
make a giant one out of cardboard, soak it in gasoline, and light it on fire.
yeah.
Okay, chill.
Genius. And then here's my idea for a new name for the giant one. The bonfire one. The bonfire is just like a giant campfire, you know? And also
So think about it over the night, because we could spend the whole next 20 minutes doing. Do these. I'm gonna random card to ask for help. Do these real quick with your team. Max, why is your mask on improperly? Thank you, sir. Do these real fast. Sorry, I'll try to zoom in a little bit. All you really need to do is, I would like you to write them on your graph paper. Yeah.
So like the first could you do just 2 to the 4th times
Yeah.
Okay, because my dad was teaching me that last night because I was struggling.
But what he doesn't realize is we haven't technically had our lesson on negative exponents yet, so we only just barely understand negative exponents.
Okay.
We only.
Trying to, and then you got upset because I wasn't understanding.
We're in Rinald's way. I slipped that into one of our lessons like super quickly. I brought up like, okay, if positive powers are multiplication, negative power, but then we moved on. We never came back to it and used it.
I see, okay.
Yeah.
So okay. He got upset for not understanding.
Wow. So notice it says to rewrite in its simplified exponent form. But then if you want to take it and just put it just as the single number form, we can also do that. Oh,
Mr. Boulder!
she said Volvo, I just misheard. Yeah, assuming that, yeah.
Where's Waldo? You kind of look like where's Waldo.
I know. That's why I don't normally wear this other times of the year, but for Valentine's Day, I don't know, red and white, it kind of fits the holiday. Spencer! What does A turn into? And if we wanted to write it as a single number, 2 squared is? Or Brenda, what about B?
1/3.
1/3 to the first power, which is kind of silly. We could just write 1/3. There's no other way to write that one. Gust, what about C?
Huh? Oh, Y or 3?
Y
3.
3?
Yeah.
Like a coordinate on like a board game or something?
No, Y with the power. Y3.
With the power of friendship?
Yeah.
Uh-oh, Patrick.
What did I do?
Tough one here. What's
I'm not
D?
even there yet.
What's D simplify into? You can do it live.
I
You
guess-
D, Patrick, you D.
Hey, let's all be quiet and watch and make. Hey, let's all be quiet and watch Patrick do D. What? You don't want to do D in front of the class?
How do you- Is it-
I mean, I can call your mom and tell her that you refuse to do D. That,
Is it just 2X?
If you really want to
I have to grow up. X, so let's go a piece at a time. X to the third over X. What would that become? X squared and Y squared. Oh, over Y squared. Yeah. Guys, be careful because I heard a few of you say 2X. This is completely different than 2X. Remember, X squared, X squared is this. 2X is 2 of these. Totally different. X squared and 2X are not the same thing. You cannot say it wrong and be like, oh, well, that's what I meant. So that's like when you order anchovies on your pizza and you're like, oh, I meant bacon. And they're like, but you ordered anchovy. Like, it's not, you can't say the wrong thing. We have to say it appropriately. Cool? X squared versus 2X. No, they accidentally put anchovies on my pizza once. I did not order it. I was very upset.
That's sucks.
Questions? Jordan.
No, I was just saying for the X squared and 2X. If X was 2, would that be?
Then it's 2 squared.
What?
If X is 2,
Squared is 4.
yeah,
So if
Sure.
X was 2, then it would not be 2.
right. But imagine how, so then this square kind of shrinks down actually. And yeah, you're right. Then they would take up the same amount of space. They still aren't technically the same thing.
What was the end result?
The end result is yes. Yeah, I'm not arguing that.
Sorry, I just like the quadratic formula stuff.
Oh, I know. Today my Math 2 class programmed their calculator so they never have to actually do the whole thing on their own. They just have the calculator ask them what's A, B, and C. Yeah, and any of you guys can do that. All right, up here. Real fast, we got 15 minutes to fly through the rest of this lesson, or like this entire lesson. If you want, you should probably, on your graph paper, squiggly line across, write 823 negative negative exponents.
Yay!
And guys, we talked about this really briefly one day, but then I realized on your homework, because when I looked at checking your homework, I was like, oh yeah, no, they definitely did not retain that, because we looked at it super fast one day.
Can we relook at it super fast? Can we
Yes.
relook at it?
Just not as super fast. If positive exponents, hey, you can only eat candy if you're not making like a deal out of it. If positive exponents are repeated multiplication, what are negative exponents used to represent? Nevin? Negative division. What? Repeated division. So negative exponents are used to represent repeated division.
I thought it was just repeated minus multiplication.
Exactly why we're looking at it and writing it down instead of continuing to just hold on to our hair so it doesn't fly away.
What?
I don't know, but Jake looked like he was holding on for.
I thought you were talking about.
Is that a toupee? It's a very good toupee if it is.
There's a lot of glue.
It looks really good. They fitted it to your head well.
I don't want your toucan to take the toucan today. What? What?
I would say the word two.
Oh my. Shoot.
So, for a moment, check these out. Which ones of these are wrong? We are looking for the mistake. So you're becoming Mr. Hudson again, right? Find who messed up. Now hold up. With my random cards, I'm going to ask for, tell me one of these that is wrong, and how would you explain to them why it is wrong and how to get to the right answer. So take a minute. Two of the problems below are correct. 4 contain errors. 4 of them contain mistakes.
The first one's wrong.
The first one's right.
Speak in your head.
No.
I know what I said.
Wait, what?
You know, if you gave your brain a moment to think without you talking,
It's Jake. That's impossible.
ironic that you're, you know. You're calling out Jake for talking, but in that moment, you yourself are doing the Jake thing.
But I'm me.
I know, you're Mr. Right.
But he's wrong. No, I can't be wrong. I'm Max right.
All right, Jake, you got lucky because you're the first one. Point out one that is wrong and explain to me why.
B, because 3 plus 4 is not 12.
What did they do? What trap door did they fall into?
They fell into the fact that 3 times 4 is not is 12, and they have to add them.
If this was written like that would be 2 to the 12. But this, as Jake said, should be 2 to the 7. Questions on why? No. So if your hand is up, it means you're confused. Connor, are you confused? Okay.
Can I go next?
Walter, I have a deck of cards in my hand. This is not new. Walter, give me another that's wrong and explain why. Sorry, which one? D as in dog? Okay. Hey, if you're not Walter, shut it. Walter. You're right, but why? It is wrong. Yeah, the bases of 3 should stay the same, and this should be 3 to the 7th, not 9 to the 7th. Very good.
They got the opposite.
Renal, give me another one. One of these is kind of tricky. You guys might not know this yet. So I might have to take volunteers for the last one. C is actually right. It's a little complicated of how they get there, but there's one more 7 on bottom than there is on top, and one more 8 on top than there is on bottom. So this actually checks out. You can pass if you want, or you can try again.
No. Can I try? No. Pass means he's going to pass hard. It's not my choice.
I mean, you can phone a friend if you want. We'll let that fly.
My turn for because it is the same on the top and bottom. It's 1.
F, this, and guys, I would like you to write this down. Z to the 3rd over Z to the 3rd. If I subtract these, like the rule we're about to get really good at using, it's Z to the 0th power. This is tricky because a lot of people think that's 0. It's 1. Are you okay? That's what I thought
It's
too.
a giant 1.
It is a giant 1.
It's a bonfire crack.
And then, which other one is wrong? Anybody? Anybody? What should it be? What should it be? Negative 3. I'm off. I said anybody. You just shout it out. So, hold it. Here's why. Here's why. Because I got only 10 minutes left. With A, we should already be pretty comfortable with this. This would be 2 times 2 times 2 times 2 times 2 times 2 times 2. Right? That's how it becomes 2 to the 7th. But here, there are 8 2's on top, 5 5 2s on bottom, and that makes 5 of the first digit in the counting structure. That is a large one. That is, I'm trying to say giant 1, but not say giant 1.
Hey,
So this ends up being 2 to the
third.
So guys, we should be starting to get into this habit of, oh, this is just subtraction. Not saying it's the E word, but it's really subtraction. Now hold up. Try C and D on your own. Like, write them down because there's opportunity to make mistakes here. So try C and D on your own real quick. Which means your pencil should be in your hand, not your hand in the air. I'll come back around.
I'm not gonna do that. I will.
Yo, this is on 823. This is on your class handout if you want to pull it out. Yeah. You had what? They had to redo D. Some days you don't do D well enough the first time. You got to go redo D. This is on your handout for 823, by the way. It is on your 823 handout. That Anna's like, crap, I shouldn't have turned that in already.
It's so sad. You turned in your 823 already? Well, it's Anna, of course she did. I was doing and she did the whole page with our homework.
Yeah, and that all happened last week, too. So, like when we have the distributive property, this is really going to become 5 to the third x to the second to the third, which is really x to the sixth. Now, 5 to the third, this is one that we should start to get comfortable with, is 5 times 5 times 5. What's 5 times 5? 25 times 5 again. 125x to the 6th.
But can't we say 6x?
No. So hold on. Colin, does this make sense to you? Were you being goofy or do you actually... Okay, because you said times 5. We're done with the... This is 5 cubed.
Yes, I know.
Okay. Max?
Is that because with like the 3, since it's outside the exponents, it like distributes to all the numbers?
Yeah, so it makes this, thank you for asking, it makes this really do this. If you would like to write out, this is what we call the factored form. And then I really have 5 times 5 times 5, x squared, x squared, x squared, so x to the 6th. Does that make sense? So then, Lily, you want to try D? Sure, if you'd like to do D up at the board.
Whoa. We're
Guys, if you've ever wondered, like if I was speaking the truth when I said if you teach middle school, you kind of don't have to grow up, we're making duty jokes.
On camera. On camera.
Trust me, a lot worse things get said in other middle schools.
Why is it writing brown? Oh, I wonder.
Ooh, sorry. 4x. Hey, pay attention because Lily's doing this right so far. 4x, like that quantity squared is 4x times 4x. But 5x squared is then times 5 times x times x. And all of that's one big multiplication. Lily just was running out of space. But actually, I might see if I can fit it up there because I don't want anyone to be confused. Yeah. So then, go ahead and keep going. No, it's 4 times 4. Yep.
And then that time, and you can't very well combine that with 5x squared though.
Ooh, but you dropped an x. Where'd your other x from the 4x's go? Or you need a power. Aha! There we go.
5x squared. So
Aha!
Now you can combine it, and you get 21x squared.
Ooh,
What?
do we get 21?
I got 21 times
The
x
fourth
to the
power. Yeah.
That's multiplication, not addition. Look at it again. Don't look
Yeah.
at it. Hey, she's got it. She's backing up. She's in reverse.
Hold on, I'm not doing this in my head.
It's a big one to do in your head.
I know.
What is 16 times 5? Okay, because she already figured out, wait a minute, I accidentally added instead of multiplied. So we need to do 16 times 5 now. So we get 80x to the 4th. You all right?
I have a question. I got 21 times.
You added instead of multiplied. Thank you.
I got 21x to the 4th.
So, watch. I'm doing it again. I'm doing it again. Doing it again. And this might be a little tough to see for some of us. What Lily did is absolutely right. The trap door is mixing up addition versus multiplication. So this is 4x times 4x. Multiplication between all of them. Times 5 times x times x. If I write out the whole thing. If I move things around to make it nicer, I have 4 times 4 times 5 times x times x times x times x. So now I do these. I mean, I could do 4 squared times 5, but that's not really nicer. So I do 4 times 4 times 5, or 4 times 5, 20, times 4, 80, and then all of these can be written together, x to the 4th. There is not a single addition in this entire problem, right? It's all multiplying with each other. Do not fall into the trap door. Sorry, that's supposed to be multiplication. 77 is also, let's go to 79. I'm skipping around, but I'm trying to make it through this. So, 8 times 10 to the negative second is scientific notation, but what it's actually telling us to do is 8 divide by 10 times 10. Right? The negative exponent actually means repeated division. So that shifts our decimal over 2 places and becomes 0.08 millimeters. That is very small. We start to have to use like micrometers and special measuring tools.
Wait, is that almost as small as an atom weighs?
I think an atom is still much smaller than that.
Yeah, it's
That's
the
more
0.000.
That board really did not like that girl.
Write out number 80, which is on your paper. Write out 6.278 times 10 to the negative 7th. If this is your chance in percent form of winning a certain lottery. Which actually, when you look at like getting every single number right, this is still probably higher than most of them.
Well, at least one person gets it every time.
Has anyone like figured out sort of like a mental trick for helping them do these either negative or positive? Jake?
I have, so I just, so I see that there's, the stuff, like the numbers, and then sorry, it's just distracting of what you're doing. And then I just, like, for positive, I just add.
There's a little operation we got to do on the in-between.
Never mind.
Anna, you had your hand up too?
Oh, the one, well, this is just like what I use in my head, which isn't like necessarily math memory. But if it's negative, then I look at the numbers on the other side, like the positive, like whole number side of the,
Yeah.
oh my gosh, the decimal point, and then I count that in, and like let's say it says 7, so I count 6 as 1, and then I add.
Yeah. Guys, there's always a single digit right here. So if I'm shifting my decimal left, just take 1 away, which would make this 6. And that's how many zeros we're going to need. 1, 2, 3, 4, 5, 6. Then 6, 2, 7, 8%. That's percent, like Yeah, so do you think you're going to win that lottery? You have a chance. You have a chance. We're like out of time, so really fast. Nevin? No, they said percent. They didn't give me the percent symbol, but they said percent. So changing this number directly into, we still have percent. They already gave us percent form. Sorry, you're right. Normally we would need to do that. Yeah, we'll finish up the problems on the front of this tomorrow. It's not your homework. We'll do it together. Brenda?
You said take away.
I'm saying take away from the 7. Not the -7, because we know we're going left. So, you're right. But the negative, I said I'm going left. And now I'm just thinking of the number 7. Does that make sense?
Yeah, I understood it. I got going to make sure. And then I also gained another necklace.
Oh my gosh. What's up? Yeah, you forgot like the times 10 sort of thing, right? So I just wanted to check with you really quickly to make sure you knew what you were doing. I already gave you a check, right? Yeah, I just wanted to make sure you knew what was up. You're good. Brain farts happen, man.